A researcher wants to determine if there exists a linear correlation between the length in inches of adult alligators and their weight in pounds. The following data was collected. Use it to answer the following questions. So we have some different lengths of alligator, and we want to see if that's a good predictor of its weight. So our input variable is going to be the alligator length, and the output variable, the dependent variable that is, will be its weight in pounds. Now, the first thing we need is the correlation coefficient. To get that, we'll use the calculator and the linear regression function, but first we need to type all of our data into a list. So go into the list editor by pressing Stat and Edit. And if you have any items already in your lists, just highlight the name of the list, press Clear and Enter. And then go through and enter your data. Make sure you take care to double check that you put the correct data in, because if the calculator is doing all the work for you, then it's very difficult in order to determine if you simply typed in a piece of data improperly or if you've done something procedurally incorrect. All right, just about there. Great. Now, to do the linear regression, we're going to press the Stat key, come over to the Calc menu, and find the fourth item down for me. It might be different for you. And you might see a menu like this, or you might not. If you don't, that's okay. You should see the function linreg ax plus b on the home screen. And in fact, you actually can just press enter it this time, if that's the case for you, because it will by default use L1 as its X list and L2 as its Y list. But if you would like, you can also press second and 1 to put L1 first, then hit a comma, and then second and 2. It'll have the same effect. Now, if you're seeing these menus, make sure X list is set to L1, Y list is set to L2. If not, just hit like second and 2, and that'll make sure L2 shows up. Be certain that frequency list is clear. That can lead to some problems there. And also just leave store regression equation clear as well. Then press calculate, and it will come up with the values for you. So the correlation coefficient is the last item here, in this case 0.907. And if you didn't see that correlation coefficient show up on screen, if you just saw the values A and B, then what you can do is press second and catalog, and you have to scroll down until you get to the D's, but you're looking for an item that says diagnostic on. And that's some statistical diagnostics that the calculator doesn't always turn on by default, but you can set them to turn on by choosing this function and pressing enter twice. Then the next time you go to run the linear regression, it will make sure to provide those values for you. Okay, next we want the equation of the regression line, and the first two items, A equals 5.52 and B equals negative 4.11. These are the slope and the y-intercepts of your regression line. So we say y equals, what was it, 5.52 times x, and then minus 4.11. Okay. And lastly, predict the weight of an alligator that is 72 inches long. Round your answer to 2 decimals. All right, so if we have an alligator that is 72 inches long, this is an x value in the data set. So you plug that value into your line equation in order to get a y value back out. So 5.52 times 72 minus 4.11. let's see, 5.52 times 72 minus 4.11 gives me a prediction of 300, says to go to 2 decimals, so 393.33 pounds. Okay. Would it be meaningful to use this model to predict the weight of an alligator that is 246 inches long? Well, the problem with an alligator that is 246 inches long, if you look at our original data set here, the maximum value is only 123. So 246 is very far outside of the range of our data. And it's not a great idea to go far outside of the range of your data in order to get accurate predictions. So I would say no, that would not be meaningful. And the reason why or why not is that the value is outside the range of the original data.